Good morning, good morning. Hello, happy Sunday, everyone. Today's gonna be a longer stream day again, because, well, no work today, it's Sunday. The schedule is remaining for next week too, so that entire like Monday, Wednesday, Thursday thing. I do realize that I completely forgot to sort of update the schedule like I kind of promised that I would, so that was bad on me. I'll have to actually do that this time. But today I have sort of like two things planned to do. First, I got another report that we have a bug in the ECS course. Specifically, the bug is around the XOR. If we delete a component and possibly an entity twice, I think it might be just in a component though, then it re-adds it back in. If you delete a deleted component. KO2 fan, hello, good morning. So we are dealing with that today. So that is this one. All right, so the idea here is it's gonna be probably in entities itself. If we delete a component twice, it re-adds the component back in, which is not necessarily what we're looking for. Let's go ahead and test that out for ourselves. Okay, so function we want to cannot delete components twice. All right, so what do I want to do here? I want to I guess create the entities, register components, create the entities struct. So let mute was entities default. After we create that, then I want to register a component. We can just do our standard U32 for this. After we register a component, let's register. I don't know, actually, if it matters if I register 2 or not. Like that basic math works, I think. So, because this will just be the 1 bit on it. So like 1, 1, 0, it won't really matter. Okay, so then let's create a component. Entities, create entity with component, and then let's just give it like a 10 U32. Okay, so we create that, and then I want to be able to delete the component. Chantilly Cake, hello, good morning. So we're gonna do entities dot delete component by entity ID. So 0. Now let's double check the map that we have in here. So inside of our entities, we have the map. So we should see the first one should be 0 because there's no components in it. Okay, that makes sense to me. Like it should be 0. So we should be able to do an assert equal that entities dot map of position 0. That should be equal to 0 now. And I'm pretty sure that's exactly what we're gonna get. Now I haven't like recreated the array yet. Oh, cannot delete component. Oh, right, we have to tell it what component to delete. So in this case, it's gonna be the U32. Okay, now if I have 2 components, because like a maybe more realistic thing here is, let's give it like an F32 too. And so I say like with component 100, something like that. Now you're a 1 and then you're a 2. So we should expect though it'd be 3 total, but then without this, it should just be a 2. And okay, it passes. Now, if I delete this again without re-adding it back in, you should still be the same. This should still be 2, but the report is that this is actually going to be a 3 because the XOR that we do says, hey, it doesn't exist. Let's re-add that back into the map, which is obviously not exactly what we're looking for. And there it is. There's our bug. We have a 3 when it should still be a 2. So how are we going to fix this? I'm thinking that we can do an if statement to see whether or not it has it right, it has it to begin with. When we delete, it shouldn't take away that much performance from it. So in our delete component by entity ID, I first want to see if it has the bit set on it, which, so we get our mask. Yeah, we do this. So if it doesn't exist, if that's a negative, then we want to do a then we want to not do this at all. Darth Millennial, hello. It is going pretty well. I'm happy that it's a Sunday. Don't have to go to work today, and I get to hang out with you all today. Let's go ahead and play around with this a little bit in our dev tools. So it's actually going to be the exact same. I don't know what do we call it? It's the it works exactly the same in JavaScript as it does in Rust. This is sort of like just a normal programming thing. Most languages have something like this implemented, so it should be easy to sort of like recreate this here and play around with it. So you won't let me. Okay, fine. Let's do a bar. This is going to be our map, and we're going to set this equal to a 3. So that means a 1 has been set. So if I want to see if this is set, can I do map or like essentially, oh, how do I do binary with this? Map or, and then it's 0, 2. So map or 2. So that gives me this 3. Oh, is it and? Ah, that gives, okay, the and. Okay, so then if I do a map or, let's see. 1, 2, and then it's 4, I think. Yeah, 1, 2, 4. So then if I do map or 4, which would be 1, 0, 0, that'd be 0. Okay, so you don't exist there. You don't exist there. So if this was a 1 because the 2 position didn't exist, then this becomes a 0 because there wasn't there. Now if this is a 2 because it's like 1, 0, then checking this one out would give us this 2. So we want to see if it's a 0 when we use and. Okay, so the way we're going to do that here is if self.map index and mask. Okay, if that's equal to 0, then we're done, right? So if it's not equal to 0, and actually really if it's equal to the mask, we can also do that. If it's equal to this mask, then we have that thing. Then let's go ahead and remove it. Now I want to say I do this exact thing somewhere else here too, but I'm gonna make sure that this works first. So let's come down here to this test again, run you, and now you're passing. Okay, perfect. And I'm thinking that we should be able to I mean, that's a pretty simple fix. Where else do we do an and in here? Oh, that's it. I have like and. Okay, so this is the only place that we just do and space, like space and space. Okay, so then I don't need to like do anything crazy. Although I could like easily see that this could be hard to tell. So I might create a method for like does have component. Yeah, has component. If that's a method on here, then I could call that, sort of like give a name to what this is happening, what is happening here, and then that works. Yeah. All right, so what I'm gonna do is I'm gonna go ahead and refresh this. We verified what the fix is and how to do the fix. I kind of like this idea of playing around with it, so I'm gonna just hit refresh. Yeah. I don't care about you. Okay. So let's oh, my recording and video timer is up. Okay, so we're gonna do prepare for streaming, prepare for recording, and we're gonna create this fix. Hello, and I have a bug fix that we need to make for our ECS library. It turns out that if we were to attempt to delete our components twice in a row, it would essentially re-add that component. Let's go ahead and verify that that's actually true with a test, and then we'll go ahead and implement the fix for it. So going to create a brand new test here at the bottom of our entities file. So function should not re-add, should be able to delete components. Naming things is hard. Should not add component back after deleting twice. Sort of like a little bit of documentation in here to make sure, like, hey, that, you know, if this happens again, then we know that we've somehow screwed this up, and we've got some kind of like reversion, and we need to fix that. Okay, so first off, we're going to start, just like all of our other tests, we're going to set up entities for ourselves. So that mute entities equals entities default. Then we need to register some components. In this case, let's register 2 components so we can really make sure that it's like that, you know, in a more realistic scenario, like if we have like, you know, a 1 in that position in the map and then another one next to it, so that would be like 3 total, and then we remove one of them, it's either going to be a 1 or a 2. So let's make sure we have something like that. So entities, we're going to register component. In this case, let's register a U32, and let's also register an F32. Once we have that, let's just create a single component or a single entity with both of these components. Okay, so with component, our U32, let's just do something like health, let's say. So it's 100 U32. Okay, that's easy enough. And then we can do another component. Let's say this is something like a location or like a speed. So that could be something like 50.0 F32. Okay, so we've created this entity with 2 components. I should now be able to, and I don't really care about querying for it, so I don't need to do that entire thing. What I can do is just check the map to see it's exactly what we expect it to be. Now we have that sort of part tested separately. So really what I want to do is delete one of them and then just check to see, is it what we expect it to be? So let's go ahead and do that really quickly. I'm going to do entities dot delete component by entity ID. We're going to do ID is 0 because it's just the index. And then the component we're going to create, let's create that, let's create the U32. That's what we're going to delete. So if we think here, the U32 is the first one that's registered. So that means it's going to be the 1 in the 1's position. So after we delete it, instead of 3 in the map, it should be a 2. So let's go ahead and just assert equal that that's working as we expect it right now, which it absolutely should be. So assert equal entities.map of position 0. We expect U to be a 2. So if I save U and see what are, there's a result here we need to handle. If we run this, it works. Okay, excellent. That's exactly what we wanted. Now the report that we got was that there's the error is that if we delete a second time, then it's going to re-add the component back in, which makes the map be a 3. So let's now delete you a second time, and now we want you to be a 2, but we're a little bit worried this is going to be a 3. Oh, and it is. Look at that. Left is 3, right is 2. So what exactly is going on here? Why is that happening? Let's come up here and take a look. Okay, so in our delete component by entity ID, we get our type ID, we get our mask, and then we figure out, okay, we do this XOR. So the XOR is basically saying if you have this, remove this. But the problem with XOR is, and I'm curious, I think here's like, this is JavaScript, but JavaScript and Rust both share a lot of the same bitwise operations. So we should be able to do very similar things here. Let's say that we have a map that is a 3, and we do a and equals to a 1, and we run that. Oh, I need to like do something like console log. Oh, that won't let me. I need to actually assign this into something. So like var, I don't know, like the map equals 3, and what was it? The not equals 1. Oh, it doesn't like. Oh wait, no, I know what I'm doing. I have to set it to 3, and then I can do map that equals to 1. And we see, okay, it's a 2. But if I do this again, it's back to a 3 again, because it's basically just saying, hey, and or. It's, do you not have this? Add it in. Do you have this? Remove it, which is really nice, but that's not exactly what we want it to be. So we need to figure out a way to tell if it exists in there. And if it does, don't do that. So that's sort of like coming back into here and saying, okay, so if, I'm just going to do a little bit of pseudocode here. If essentially map has component. So if map has component, then I want to delete this. Okay, so let's figure out how to tell if something has it without actually updating the thing. So I have the console log map here, so we should be able to tell what this does here. I want to do this map at this point. Let's do a OR, and if I do that, we'll see, okay, I get a 2 with this 1. That's not exactly what it is. I think that's the opposite, where it's showing me what doesn't match. What if I do an AND? So the AND should be checking if the ones are aligned together. So AND here. And we have a, oh, we should really be console logging this. Okay, so that's a 0. So and 1, because the 1's position doesn't line up. If we have a 2, the 2's do line up. So the 1 and the 2. Okay, so we want to use an AND here. If we did an OR, it'd be the opposite. We would not be getting what we want. So let's do the AND. So map has component. We kind of have everything that we need here. So self.map of index, and then it's just going to be a single and then our mask. Now we can check to see if this is 0, we don't want to do anything at all. But if it's equal to the mask again, then we know we do want to delete it. Okay, so you're equal to this, then do this thing. Okay, so let's save that, head back down here, and rerun this test. And now it's passing. Okay, so is there anything we want to do to like make this a little bit nicer? Creating this into a function might be nice, because then we can basically hide some of this complexity in behind like a name, essentially giving this a label. So instead of having to document this with some like, if this exists, if the component has this has the mask of the entity, what if I were to create, so just a private function here, has entity. I guess it would be has component. Has component, this would just be a reference to self. We probably take this type ID, probably take the type in or the type ID, because we kind of need the mask to delete it. So yeah, we'll take in the mask. We'll take in the mask and we'll just return a Boolean, true or false. So take in a mask. Now in this case, we know that the mask is a U32, and we'll return a Boolean. So all we need to do is this thing right here. So copy U, just throw U straight in there. So self.map of index. Oh, we need the index too. So index is going to be a U size. And then you don't need to be destructured there. We're going to do that above. Okay. Then we're going to use this. So delete component. So here we're going to say self dot has component, pass in our index, pass in that mask, but we do have to dereference it. And then we can go ahead and do this entire thing. We could also put this into another function too. Let's go ahead and run this test again, make sure it's still working. And it is. Okay, excellent. So then our very last thing to do is just to run all of the tests, make sure that they're still working. And then we can go ahead, bump the version, push this up. It will auto deploy as soon as that's done because of those the GitHub actions, and then we'll be good to go. Anyways, thank you so much for watching, and I'll see you in the whatever the next video is. Thanks. Bye. All right, and let's go ahead and actually do that bump too. Cargo to Toml. So you're a 1.02. Add you both in, and what did we do? We fixed a bug where deleting components could add the component back. Can I, how do I do like the description? Is that just the normal message too? Hold on, let me. Okay, so I have these added to be committed, so we can just do git commit. You don't really care. Okay, so git commit, we are going to be fixed a bug in entities where deleting a component twice would re-add the component. Thanks to YouTube viewer. I need to find out who reported this. Where's my comments? Oh, where is it? How do I search it? Filter for maybe bug? No, that's not it. How about just and I know he or maybe the XOR. Oh, there it is. Okay. Um that's come on, go back. I lost it. There it is. Okay, so it is Brendan Stanton. At I guess I can't use at for that. According to this, username Brendan Stanton. Okay, got it. Then we'll go ahead and push this up, and that should be good to go in like 10 minutes or so. Which also then I can now reply. Okay, so that is good for that. We can rename this entire fun thing. It's recording. So you are, I guess like it's addendum. So like bug fix, deleting components, deleting components twice, re-adds, or fixing, I guess. Fixing a bug where deleting component twice re-adds the component. All right, a long title, but good enough for that. Okay. Which means it's time for us to dive back into the Rust standard library. So I can go ahead. This is all good. I don't need you anymore. Go ahead and close you all off. And let's dive back into the Rust standard library. And I need to find out where we are on this. Oh, I think it's in here. Yeah, okay, got it. All right, so looks like we're about to get into convert try from. You're yelling at me for some reason. I got 5 errors. If false or false, yeah, okay. So I think I was doing some silly things. Yeah, you're gonna be unhappy. Let's go ahead and quickly fix some of these. That way Rust Analyzer is just not yelling at us constantly. So, turn you off. Assert. And throw this on here. Do I have to do it on line before? I do. Okay, so then that makes you happy. You. Oh, copy may not be implemented for this type. Right. So field is never read thing, so I'll just make you that. Oh, you're never read, but apparently I can still do that. Then something, oh, thing, like that. Okay. Yeah, something else. Lots of underscores. You're implementing hash explicitly, but have derived partial equal. So yeah, it doesn't like this either. Oh, can I? Oh, I can totally do this. I can allow this. Don't bring that in. Okay, let's see. Equal expressions as operand to equal equal. Deny clippy equal op. Oh, that's weird. Okay, let's bring that in. Clippy. Unknown lint. Wait. Did I just do that wrong? Oh, clippy. That's what. Okay. Let's see. Allow. Oh, equal comparison of unit values detected. This will always be true. Oh, and then we have to allow you to. And oh, well, okay. No matter what, it won't let me do this. Fine. I'll just comment it out. Identical arguments used in this assert equal. Yes. I mean, sure. Okay, functions never used. Kind of want to just allow you. So we'll allow dead code. Function variable Jane here. Unused variables. So allow you to. I'm gonna guess you're unused, but I was. Oh, we can just underscore you maybe. Never used. Never used. Assert false should probably be replaced. Yes, I mean, you're allowed. So all, okay. So fine. Turn you off, then we can delete that. Okay, we're getting close. We only have 10 of these left. Oh, use of a blacklisted placeholder name. Really? Okay. Acute, unused variable. You're unused too. Constant is never used. Can I underscore that too? Oh, I can. Okay. Field is never read. This ID. That X is never read. This new function is never used. Yes, I know. Here I think we can do the warn dead code on this one. I think that would work out. Or allow dead code. Okay. No more errors, no more warnings. We're good to continue. So let's go ahead and all of you in there. Removing warnings, errors from the examples. Okay, now we're ready. Okay, so what are we looking at again? We are going to be looking at try from. Why don't you show me? Oh, am I just opening examples here? Is that all I am? Oh, this is it. Okay. Try from trait. I think it's try from trait. Yes. Okay, let's get into it. So we have this standard convert try from. Simple and safe conversions that may fail in a controlled way under some circumstances because it returns a result. It's the reciprocal of try into. Oh, Raven Legend. Hello. And you redeemed Pet the Cat. You know, I don't know if Zilby is down here right now. He's been sort of hesitating to come down because of the green screen that I have back here. He had an incident with it. Zilby. I'm gonna see if he's just right behind me, if, you know, hiding. If not, then we'll just wait, see if I can find him later. He's not here. He must be upstairs. If I'm gonna leave this here, and if he comes down, I'll redeem it. Otherwise, I will refund your points. All right, where were we? Simple and safe. Okay, so it fails and it's the reciprocal of try into. This is useful when you're doing a type conversion that may trivially succeed, but may also need special handling. For example, there is no way to convert an I64 into an I32 using the from trait, because an I64 may contain a value that an I32 cannot represent. So the conversion would lose data. This might be handled by truncating the i64 to an i32, essentially giving the i64's values module i32 max, or by simply returning i32 max, or by some other method. The from trait is intended for perfect conversions. So the try from trait informs the programmer when a type conversion could go bad and lets them decide how to handle it. So is does that mean no? Okay, so look, try from is implemented on other ones. Okay, so it is implemented elsewhere. So it's not like we have to implement it 100% of the times. So try from is a conversion from one type to another, but has can lose data when it converts. The example given in the documentation is for an i64 going to an i32. What if the i64 since the i64 could contain a larger number than i32 ever could, it is possible that the number would be changed to the maximum that the i32 could be. This is why try from turns a result. Okay, and then there's these generic implementations. Try from T for U implies try into U for T. Try from is reflexive, which means that try from T for T is implemented and cannot fail. The associate, yeah, so if like from one type to the same type, is that even a thing that could happen? Like, could you do that? The associated error type for calling T try from on a value of type T is infallible. Oh, you know what? I forgot to turn on all this stuff again. Let's do that. When the bang type is stabilized, infallible and bang will be equivalent. That's interesting. So infallible and bang are essentially the same thing. Now we looked at the bang before, and it's essentially a like nothing. So try from can be implemented as follows. So let's see, we do a try from for i32 for like something. So in this case, a greater struct that wraps around i32. Looks like it has a type error, which is going to be what the type of the error that we're going to return is. That's interesting. So are they recommending using static, or would it be better to use something like error or anyhow to create an actual real error? Function try from value 32 result self error. If value is okay, so if it's less than that, we give it this error. Otherwise, it's okay. So let's try doing this. So let's do our entire location again. So let's do like a struct location. you'll have an X32, a Y F32. So we want to impl try from. Now here we're try from like something like an I32. That's interesting. So like I guess I could have it be an array. So like F32, something like that for location. You're not happy with me. Oh, I think I can't do that. It has to be something like this, an F32 2. Yeah, that's what I need to do. Then let's implement. Wait, what? I'm used to REST analyze. Okay, implement missing members. There we go. REST analyzer sort of got a little bit confused there. Okay, so we're gonna have our type error. Now, I don't want to make this a stir, like a static stir. I don't feel that that's I don't feel like that's like the right way to do this. I almost feel like we would want to let's pull in anyhow. Oh, we should in crates. So we want anyhow. I think that's it. And I don't think we need to do anything else necessarily. I may have to remember how to do this. So we have an enum custom errors. And so in this case, our custom error is going to be this one. So like, cannot convert. So let's see. Cannot convert into like location, or cannot convert into for some reason. Then have our error equals, you're gonna be, oh, is it like that? Error cannot convert into target type. We can do the entire thing where we pass in like what exactly we're trying to convert into. Let's not necessarily worry about that too much. We can debug that. We also want to bring this as an error. So use anyhow error. Is it feels wrong? I need to go look this up. What is it? Crates. I always forget. Okay, so derive error. Oh, it's a this error. This error. Okay, that's what I'm missing. It's this error, not anyhow. Okay, got it. So cargo. What I really want to do is this error. I don't actually know if I need anyhow at all then. So then take a look at you. I want use this error. We're gonna pull in error like that, and then I think it will work. Null traits. Okay, so then for you, this error is gonna be our custom errors. Cannot convert into. Think that should work. Expected type found variant. Oh, I have to do the dot into, I think, for it. To then actually convert that into the trait. Expected semicolon. Expected bang. Expected an item. Oh, can I not actually do that here then? Oh wait, this is the type. This is not the actual error. What kind of error would this be? Well, that's not a type. Is there this error? That's a trait, not a type. Or that's a derived macro, actually. I guess the standard error maybe. Trait objects without explicit dying are deprecated. Okay, so can I can do that. Okay, so then here. Now we're just yelling at us that we're not doing the thing properly. So we have this F32 and 2, and for I guess if we want to do something like, if you try to give us a number that is less than, like, I don't know, less than 0 for some reason, then we're going to return an error. Like you're too far off the screen. Okay, so in this case, we have this value coming in. Oh, this could also be a generic, couldn't it? But let's do it for this. So it's from this F32. So let's say for some reason, if value of like 0 is less than 0, or value of 1 is less than 0. So if either of those are less than 0, we're going to return an error here. So we're going to return error, and then we're going to have this custom errors cannot convert into. I think we have to do the into here. Now, if we get past that, then we can go ahead and create what we're expecting to. So this is going to be an OK with a with our self and then the self error. Oh no, just the self. So an OK, and then this is going to be the self. X is value of 0. Y is value of 1. You're unhappy. The size, values of type, die, center, error plus data cannot be known at compilation time. Trait marker size not implemented for dine. Okay, so I need to figure out what the type for this error is. Like, so I don't think I can use dine here, because otherwise I could just say like dine this. Well, actually it's already a dine, isn't it? But it won't let me do that here. So you have to not be dime. So I need an actual type for an error. And this is a trait. I guess that's our problem. We have to go find a type. For error. So, okay, standard format error, the error type. Maybe we could try standard format error. Okay, so that got us to here. So if you have to do the 0.0 to compare against those. Then the trait is not satisfied. Required because the requirements of the impl of standard convert into for custom errors. Okay, so we do derive error here. Do I not need the into? No, because you. So I expected the struct error. Do I just return this dot into? And then it converts it into an actual error? No, it does not. Oh wait, do I tell you the type? It's anything that implements format error. So how do I use that? Or is it a completely different thing? Oh, then we can use anyhow. But that produces an anyhow error. We could try bringing anyhow back in and using that. Does that macro create an actual error? Okay, let's bring that back in and see what we've got. Okay, so bring you back in, REST analyzer, you do your thing. Let's also, let's say our error is an anyhow error. Well, you're a struct error, so that's the type, okay. Then, so I want to return error, anyhow. What was it? There's a macro somewhere in here. Anyhow. And then I think it's going to be the actual. Oh, these are just one-off error messages. We can just do that. Or I can throw this in there. Custom errors. Can I convert into? Expected struct error. Fun. Okay, so now can I do my into? Yes, I can. Okay. Perfect. So let's actually use this. I want to so let's like say I have some kind of array. I want to create my location. So we're gonna create a location is equal to location dot try from oh, it wouldn't be dot. Okay, we're gonna try from, and our value is gonna be just like this, I don't know, 15.0, 10.0. This gives us a result. So I'm just gonna go ahead and unwrap you, and then we'll just debug our location. So if we run this, we should be able to see there. Okay, so we successfully converted it from that array. Now I can do it with tuples and many other things if I really want to. Okay. Now if I have a failed state, for example, like I make you a negative here, and we try this again, we should get the unwrap with the actual error printed out, which is here, cannot convert into target type. So perfect. That's kind of exactly what we want. Now, let's say I want another try from here. And was there another? No, there's no other methods. So impl, try from. Something that might make this more interesting here. What if I have a like an I32 and I want to convert it into a location which only has F32s. So maybe this will be a tuple. That kind of makes sense, right? So we have like an I32. Okay, we're going to do the same thing with our error. So this is going to be an anyhow error. Now our try from here, we're going to take in this tuple of I32s, and we're just going to convert them into F32s. Now, can we actually do that? Now we're returning a result here. So let's try just doing like the straight up conversion, but I'm fairly certain you can't pull an I32 into an F32 due to the sizes. You can have like a bigger I32 than an F32, I want to say. So what if we just do, we're going to return a location. X is value of value.0. Y is value.1. Now we're going to, now if I do into on this, I think you don't work. Because we can't convert. Yeah, we can't convert from an I32 into an F32, but I believe that there's a try from into that. Let's try a try into. Try into. And if that fails, we're going to question mark you, which then should just go ahead and return what this result is. Let's see. You are expected. What kind of location are you? Construct location. Oh, and you need to be in OK. In the case that it succeeds. You, the trait bound F32, convert from I32 is not satisfied. What, you won't let me even do a try? Oh, I think I have to do, I guess I can't do a dot on an I32. Oh, that's too bad. Okay, so let's try something else then. Let's try an F32. Try from an I32. Oh, and you wouldn't be that. You'd be the value dot zero. I guess it's not implemented on that type, so I can't really do it myself. I was kind of hoping that it would be implemented on that type as like a try. Maybe not try from, maybe try into. Expect an F32, found an I32. Yeah, I want to try. Oh, I32. Yeah, it just won't let me do it. That's too bad. I was kind of like really hoping that this would work. So we've got to do this ourselves then. So in I32, if you're greater than the maximum of the F32, then we have to use that value. So we're gonna have to use let x is gonna be equals to, if we have to do this conversion ourselves. If the I32 is, so if value dot zero, if you're greater than the F32 max, self and other. Oh, wait, not max like that. Max. So if value is greater than that, then we're going to turn the max, right? So F32 max. Now, else if, what if you're lower than the minimum value? So if value dot zero less than F32 min, then return F32 min. Okay. Otherwise, now here's, can I take this and like convert it into F32 knowing that we have done all this hard work so far for this? Oh, and I can't actually even compare that, can I? Can I do this as an into? Because bringing the I32 would be bigger. No, I can't go into an I32 from an F32 either. Yeah, so I don't let's see. What are different ways that I could get get that information? We can go take a look at the types. We haven't deep dove into those yet. It's like F32 or maybe I32 itself. Oh, there's gonna be so many things we're gonna look at once we get in here. Okay, so we have these try froms, and we can see that they don't exist anywhere else. I don't see. Yeah, there's nothing for like any of the floats. Which is unfortunate. Now, how about the other way around? Can I do an F? So there's these floats to ints. I can do a float to int I32. Oh, that's on I32. Oh. So that's I32. Oh, it's not on I32 itself? Look at this. Okay, so impl float to int. Oh, it's a macro. But I can't actually see them. And then with this F32 into any of these things, which includes the I32. So what does that actually give us? Here's our macro rules for that. So we take the identifier. Oh, it's unstable. Oh, so okay, so it's not ready for us yet. So I can't actually do this. Not in standard Rust. Maybe in nightly I can do that. Or if I turned on unstable features, then I probably could then convert it over. So that's unfortunate. So that means I can't really do this with an i32. Now I wonder, can I do this with a an F64? Let's go find out if there's like a try from for F64. There's a from U32, there's a from F32 because that works. And is there a try from? I don't see any other try froms for that. So maybe there's a try from on the F32 the other way around. Maybe that'll work for us. So let's say I do this as like F64. Not that. For location, we do the normal error. Okay, so we try from. Here's our values. You are F64s. Okay, so if our, let's try to reset this again a little bit. So let our x is going to be equal to, can I convert this? So we can go the other way around. So F32 try from value dot 0. That gives us a result, and we question mark you. No, I can't. So it's that also doesn't work. I can't convert that direction either. Now I might be able to do the entire if statement because I can convert F32s into F64s. So I wonder if I can do something like that, where then we say, okay, so equals, oh, it's gonna be an if statement. If the x, so if the F32 is greater than the max, okay, so if the, it would be F64 from, and then this would be F32 max. Would that work? No, because like I'm trying to go the other direction. So if the x64 is greater than, okay, so if the value is greater than, so if value dot 0, if you're greater than the F64 version, so F64 from, and then this is going to be the F32 max. Okay, so if you're greater than that, then we're going to give you just the F32 max. But this still leads into the, like, I need to convert. I guess we do the as then at that point, right? Because that has the, like, can lose data. Okay, yeah. So far this is working. So then we're gonna return the F32 max. Nope, not that. Max. Okay. So else if the value is below the bottom. So value dot 0 is less than F64 from F32 min, then F32 min is what we return. And then finally, if it's somewhere in between, we know we can safely as it. So it's going to be just value dot 0 as an F32. And that gives us our X. And then we want to do the exact same thing for the Y. So not pretty at all. And so anywhere where we have this value 0, it becomes a 1, and it's exactly the same here. And now we can return an OK. Oh, we can return an OK. And this is going to be just like the location with X and Y. Now this one can't fail, which is kind of not necessarily like good for try from. Like the actual from would probably be best for something like this. We probably want to return an error here for these. So if so this would be return error the anyhow we have our custom error cannot convert into. We'll just use this. Oh, we can just give it its own custom error here. So this is going to be value too large to convert into location. And then I want to just take this. You become the same here. We're also going to do the same thing for the min. So value too small now. And now we should get proper error methods if we're doing a like F32. And I think it's I don't know how to do the proper checking for the other one, for like the I32s, but we could probably, like, if we figure out something for that, something very similar could work. So let's see. Let's now do let's like force it. We're gonna do an F64 max. And you're an F64 here. Now, if we do this, we should get the unwrap error. Oh, and you're going to be a tuple. So it can figure out what that type is properly. we should get the error which saying value is too large for the X. Value too large to convert to location. Now, if we don't say max here and we just say something like 55.0 F64, then this should run just fine and we get it in there. So this is a way for us to like create our own conversions essentially. And if it fails, we actually give it an error message, which is nice. So this is where I try from returns a result. I mean, it can be a little bit tricky. I don't know if there's anything else we really need to like deal with that. Let's continue. I mean, down. I guess there's the generics, but that's gonna be a little bit tougher too. So examples. I32 implements try from I64, so we can see how they use it as opposed to how it's implemented. Associated types. Okay, so we have this type error. So this is going to be the error. So the type of error that is returned in the results to allow real custom errors we can use. And then this is where an anyhow error. And let's actually just link to anyhow. Okay, we also have required methods. All right, so we have this function try from. Basically, this is the actual thing. So attempt to do the conversion and fail if it is possible. With a result. Otherwise, turn the converted value. So, if the conversion cannot fail, then no need to use the try. Great. You can just use the from trait. Okay. And then we get our implementers. So all these things that we can see, like we can go from, we can try from an I32, try from an I32 to an I8, for example. But the I's to like F's don't exist, and reverse of that is true as well. That's what I'm seeing here. All right, mostly numbers is what it's implemented on. All right, that is convert from. Interesting. Okay, so the next one we have here is mechanic ref unwind safe. So if you're wondering about like the order in which I'm looking at these, it's really like this queue that I created when looking at arrays, and that just sort of like added a bunch of things. Some other things have added stuff too, but this is still all coming off of like what we learned from arrays. All right, so panic, unwind safe. So we want ref unwind safe. This is still a trait that we're in. It's a marker trait representing, oh, it's an auto trait too. A marker trait representing types where shared reference is considered unwind safe. This trait is namely not implemented by unsafe cell. That's a struct. Okay. Kind of want to unsafe cell. Do I not have that in here? Oh no, here it is. Cell, unsafe cell. Okay. There it is. Let's add that into our queue. The root of all interior mutability. This is a helper marker trait used to provide impl blocks for the unwind safe trait. Okay, so this it's a marker trait for implementing unwind safe. Which means we should also make sure we implement that. Do we have that? I do. And then just implementations. So really there's like nothing here for us to do, which means that there's absolutely no implementations. Like there's nothing here. Like if we take a look at it, it's just empty. It's a marker. Before I forget, let's go ahead and make sure that you are good. I don't need this try into. You're so unhappy with what I've been doing, Rest Analyzer. I'm so sorry. I also don't need this. Okay. But okay, we're good there. So this is try from. Close up all these so we're nice and clean and ready for the next one. Marker send. So this is probably another marker trait, right? Yeah, this is going to be another marker trait. Now it's a marker trait to mark things that I believe can go between threads, right? Types that can be transferred across thread boundaries. This trait is automatically implemented when the compiler determines it's appropriate. So I think that's important here. Because it's this auto trait, we don't have to ever implement that ourselves. If we create something that can be sent across threads, it will figure it out automatically. So marker trait that marks if a type can safely be sent across threads is an auto trait, meaning the compiler will automatically apply this trait or impl this trait. If it determines that the type is thread safe. If two threads attempt to clone an RC, exactly. So that's going to be a problem. That's the reason why RCs are not thread safe. Now, arc, however, does, because you have to like lock the arc, and that would like pause the thread while it waits until the other one is done, which is why arcs are more overhead, slower, but also thread safe. So that's good. Okay, so that's all we need for this one. Now we have this marker sync. So another marker type. So type switch is safe to share references between threads. Right, so it's both like an auto trait. So marker trait. So it doesn't have any required methods attached to it. It marks. Now this is what does sync exactly mean here? The precise definition is a type T is sync if and only if the reference to type T is send. So it marks if the type implements send, because send is a trait, right? It is. In other words, there's no possibility of undefined behavior when passing a reference between threads. Any types marked with sync can have references passed safely between threads. It's also auto. If it needs to be. So not something we can do. I don't actually think we can manually do this, can we? That's actually an interesting question. Could I even, let's just try one of these. I'm not gonna actually do it. Let's take this location. Can I manually implement? So like impl sync for location. Like there's nothing to do here. I could just do that. But I think you're gonna yell at me saying, requires an unsafe In pull declaration. Okay, well, can I do that? I can. So I can just say, hey, you are safe to send across. Interesting. So I can manually implement that, but with an unsafe block. I don't know how helpful that actually is. As one would expect, primitive types like U8 and F64 are all sync, and so are simple aggregate types containing them, like tuples, structs, and enums. Okay, so that might be the reason why it works for me, is because I have a struct with F32s, which is a primitive type, which themselves are sync. Therefore, I can sync the thing that stores only them. More examples of basic sync types include immutable types like reference to T, and those with simple inherited mutability, such as box T, vec T, and most other collection types. Okay, so now, is there ever a reason why I would want to? I don't think so, because the compiler is going to add this on automatically. So there's no reason for me to ever manually add this in. So primitive types and collections of primitive types. Also references. So primitive types, collections of primitive types, and immutable references. So that example would be like a reference of T. All implement sync. A somewhat surprising consequence of the definition is that mutable reference of a type is sync if T is sync. Even though it seems like that might provide unsynchronized mutation, the trick is that a mutable reference behind a shared reference, that is, the ampersand. Wait. Oh, reference to a reference. A double reference becomes read-only. Oh, so it's a double reference. So a mutable reference. So it's really a reference of a mutable reference of a sync type, of a type that implements sync. Now that is like a nice caveat there. It can't just be anything. It is also thread safe and therefore implements sync. So a reference, a mutable reference. So in this case, that would be a reference of a mute of T. types that are not sync are those that have interior mutability in a non-thread safe form, such as cell and ref cell. These types allow for mutation of their contents even through an immutable shared reference. For example, the set method on cell takes a reference itself, so it requires only a shared reference. So it requires only a shared reference to cell. This method performs no synchronization, therefore cell cannot be sync. RC is another one. For cases when one does need thread safe, that's where the mutex comes in. So we do have these atomic data types. These types ensure that any mutation cannot cause data races, hence the types are sync. Likewise, ARC provides a thread safe analog of RC, right, which makes sense. Any types with interior mutability must also use this cell unsafe cell wrapper around the values, which can be mutated through a shared reference. Failing to do this is undefined behavior. For example, transmuting from a reference to T to mutable reference to T is invalid. Right, that makes sense. Like you can't convert that. Okay, so I think that's good for this. Is basically if we write things with just like primitive types, we're good to go. We can transfer them across threads. Otherwise, we're gonna have to use something like an arc and a mutex to then give us thread safety. Yeah. Now I have this marker unpin. I wonder if it'd be better to do pin first. Types that can be safely moved after being pinned. Like, oh, so that you can unpin them. So, okay. So if you pin them, which we haven't gotten to yet, so I'm not fully sure I understand it permanently yet, but if I pin something and then I want to move it, so therefore I can unpin it. If pinning it causes a problem where that's it, it's done, then you can't do an unpin. So this is an auto trait. It's a marker trait, but it's the unpin trait only when it is safe to move the type, move the value. I guess it's move the type after it has been pinned. So basically, not everything that is pinned, I guess it would be pin, right? Pin can be unpinned. But everything that's unpinned probably has pin. The pin type is used instead to prevent moves through the type system. And we're probably going to get into pin because if we have unpin, we're going to have pin too. Wrapped into pin wrapper can't be moved out of. See the pin module documentation. Okay. So basically we're just saying, hey, no more, like when we pin something, so something is pinned. I guess it's just, in this case, pinned. It can no longer be moved through the type system. Pointers P wrapped in a pin wrapper can't be moved out of. Implementing the unpin trait for T lifts the restriction of pinning off the type, which then allows moving T out of pin with functions such as memory replace. So we can then just like replace things straight inside of that. Unpin has no consequence at all for non-pinned data. In particular, memory replace happily moves bang unpinned data. It works for any mutable reference, not just when T unpin. However, you cannot use memory replace on data wrapped inside of a pin because you cannot get the mutable reference to T you need for that, and that is what makes this system work. Okay, so it's basically only when we pin, but we can try pin and unpin. I feel like I want to like do both of them together. So if I have something like our location, okay, so if I have something like that, and I want to pin this, let's say. So let's create just like instance of this location. So location is equal to location. Maybe we'll do like 10.0, 20.0. Now, can I pin? Okay, so this pin, I can do a pin new. And then a pointer. So maybe like a reference to the location. So can I say like let location ref equals location like that. Okay, so location ref. So I've pinned the reference to the location now. Now, until I've done that, I should have been able to like replace it with that memory replace. But now I can't do that. Let's actually see if I can. Can I do mem? So mem replace. Okay, so how does this work? Move source into the reference destination, returning the previous destination's value. Neither value is dropped. Okay, so we have destination and source. So destination is first. So we replace mute v, which is this thing, with a new one. Oh, okay. So now the old becomes whatever was in there. So it can become a new location, let's say. So let's also give ourselves let new location. It's going to be a location. I'm sure it's got to be the same type. So we'll do 100.0, y is 200.0. So I should be able to do this replace. Destination is going to be, you're going to have to be a mutable reference, aren't you? So you're the location ref, and our source is going to be new location. Let's go ahead and not pin this right now, and then I should be able to debug. So we're gonna debug just location. And that should have been sort of updated on us, right? You're gonna have to be mutable. Okay. Unused return value. Oh, okay, so we must use that. So like basically I'm not gonna like use that right now. So this is gonna be the old location. What's that? Okay. So if I run this, we see now that we have replaced the location. So I've just like, and it's not unsafe. Like I don't need unsafe to do that. I can just straight up replace something in memory. Cool. I don't necessarily know how I'd want to do that right now, but it is something that I can do. But if I pin this before I do the replace, so if I do a pin new, and we throw in location ref, now you're gonna yell at me because it's pinned. Borrow a move value. I cannot do this because we're trying to move the reference in here, and therefore I cannot do that. But if I unpin it, so what would that be? That would be, can I just unpin right here? Or maybe I can't do it. So there's unpin. Unpin is a type. There's a trait. Oh, that's how you do it. You get the pinned string this way. Got it. Okay, so I was doing it wrong. So we pin it like this. So really, I want to do this. Pin new. Like that. So we're pinning this location reference. Don't have to do you there. Now we have this pin, so I can't actually do that. I don't even think I can do this. Like it's not gonna let me do this because hey, you're not the right thing. Captain Jeb, hello. You're just debugging. I want to know the answer you're currently looking for, but could you just do a full copy clone and look at that way to get the debug to see what is the variable instead of all this pinning? Well, I'm just sort of like trying to like experiment with what pinning really is. And that's the reason why I'm doing it that way. Can I do that? Okay, so let's come on, rust analyzer. Okay. Rust analyzer, restart. Let's see, what can I do here? Can I clone you? So if I let's derive clone, and let's see if I can manually clone you. No, so I can't clone it to be able to replace its location. Now pin returns this thing here. Now I'm cloning the pin and not the location itself. Let's see. Now I could potentially do this. Like this is I don't think I can get another mutable reference to location. So like if I try to do mute location like that. Oh, that does let me do it. Does that still work? It does. Okay, so pin takes an immutable reference to the location in its pinned. Are you thread safe now? Is that location ref thread safe? Maybe that's the reason why I to use it. We'd have to go in and look at pin. It is sometimes useful to have objects that are guaranteed not to move. And its memory cannot be deallocated until it gets dropped. We said the point DE is pinned. So everything is movable. So memory swap remains callable for any type of P, so pin doesn't do anything like that. So pin prevents certain values pointed to by pointers wrapped in pin P from being moved by making it impossible to call methods that require immutable reference to T on them, like mem swap. Pin can be used to wrap any pointer type P, and as such it interacts with deref and deref mute. And then there's this unpin. Okay, so many types are always freely movable even when pinned because they do not rely on having a stable address. This includes all basic types like Boolean, I32s, and references, as well as types consisting solely of these types, which is unfortunate because that's literally what we have. We have, okay, so this is not the best example because this can still be moved even after being pinned, it sounds like. Okay, so it implements, I guess it's not implements because like, all of the fields are primitive types. Now, is there something that doesn't implement pin that I can like put into that easily? A string. I can throw a string in. So like, what if I do something like strange? We do description and you are a string. So we'll just do first location, do to string. Your description, and you're going to be second location. So can I pin you now? So I give you a reference to that. Now I found this pin. Can I like deref you? Ha, okay. Trying to deref ref that's fun, but it's like deref. Oh, I don't want to deref like that. As ref, as mute. Oh, still do that maybe? That needs to be a pin here. Okay, so that sort of like is just preventing me from doing that, but it feels like it's not exactly what I'm how it works like that. I don't know. Okay. It's like a double negative. Yeah, exactly. Oh, we could also use a self-referential struct. That's another way to do it. But it's okay, so you can use memory swap. So maybe replace. Can I do swap? Okay, so swap this. So swap, you take 2 arguments, mutable reference to T and a mutable, okay, 2 mutable references to the same thing. And swap the values of 2 mutable locations without deinitializing either one. Okay, so that means you are gonna have to be mute too. So I want like a mutable reference to location and a mutable reference to new location. Oh wait, what am I doing? Here. Thank you, Rest Analyzer, for that. Now that works still. It's just yelling at me that I pinned it, but it's not really helpful here. Like this still. I don't need to do that. So if we debug location, it should still be the new location. Okay, it is. Pinning, therefore, I suppose we can try to create a thread and send location into it. We could try that. So we could do thread, not thread local. Oh, it's gonna be spawn. That's right. Spawn thread where I just want to in here maybe let's try just debugging location. So if I do that, you're upset, mismatch types. Expected that, found, so we're gonna do location, 1 thread is equal to you, and then I need to join you. Okay, use of move value location. So I want a reference to location. To force the closer to take ownership of location, use the move keyword. Closer may outlive the current function, but it borrows location which is owned by the current function, which may outlive location. To force the closure to take ownership, use the move keyword. Okay. Now, can I use location ref in here? No. Also, let's not do the swap stuff. So it's still not allowed. I could do move, but location does not live long enough. Because this pin is gone. Like, even though I moved the pin in here, that now this is like not living long. So I don't think this is right either. I feel like I need to watch the John Hu video on pinning to sort of like understand when to use it. Okay, pin does not let clients actually obtain a box T or a mutable reference T to pin data, which implies you cannot use operations such as memory swap. Okay, so wait, is that what this is? Let's reset this. So can I get a, like, even if I just do location like this, I should be able to get a box of this. Let boxed location is equal to box new location. So can I do location dot, it's not like pin like that. I have to do like an actual pin. So that pinned location is equal to pin new immutable reference to location. Like that. I can still get a box location though. But what I can't do is box pinned location. That won't let me do it. Oh, and you need to be mute. No, this still works. I mean, I boxed the pinned location. And I boxed the location. I can still do that. Okay. Can I like... He's like, can I do something like that? No, okay, so I can't do that either, because it won't let me just like do an infinite recursive location, because that would be infinite size. So yeah, I guess I need to learn more about how to do things right, that I can't unpin them until I figure out how to pin them properly. So they have a suggestion of something. So self-referential. I don't know how this, yeah. Now pin is a full struct, right? Can we just go take a look at that? Oh, preventing a value from being moved unless it implements unpin. Oh wait, no. You can do new unchecked. Let's see. These are all just like swapping stuff. We could pin an RC. Okay, so we can do some RC stuff. Let's try that. Let's start over this really quickly. Well, maybe not that. Start over. So we derive. So here we have our location. Let's not worry about clone right now. Start this over. So let's say, and I don't need a string for this. Let's say I want an RC and a ref cell for a location, and we're gonna pin that. So we're gonna say let sort of like a wrapped location is gonna be an RC new. I need to pull this in. New, a ref cell new. And then we're gonna have our location x10 0 y and 20.0. Okay, so that gives me this. Can I pin this? So that pinned wrapped location is equal to pin new. So I can do. I bet this is not going to let me do it. Are you? So new, you have to be a mutable reference to like the wrapped location. And I don't think this is going to let me do that, right? Cannot bar. Okay, never mind. Thank you. It won't. Okay, you work. So I have a pinned mutable reference to an RC with a ref cell. So I don't know, like it's guaranteed it can't move now in memory. So we can do let pinned equals pinned as ref. Which means the pointee can never move again. So if I do this as ref, which was, as we can see, in wrapped location, it was a pin with a mutable RC, but now we can just get a reference to the contents of it. If I deref pin and the RC, and then I borrow the ref cell, it's like let, and I do borrowed location equals, so can I do location ref dot get ref dot borrow. I mean, I can still do that. I guess these aren't I'm doing this wrong, aren't I? It'd be like moving things, and I'm not moving them. I'm just using references to stuff. So if I have like maybe a function that implements something like this, I would have more trouble. Or that thread. But if I create like a function, I don't know, like print location, what do you take? You take in, I mean, even if it just takes a reference to a location, I don't know if that helps. If you take in a pinned, that's ownership. But I think that was still showing this working too. I think I just don't fully understand how this works yet. So, I think the homework I'm gonna give myself. Let me see if I can go find it. There's this video here that John Gangset, I think I always mispronounce his name, unfortunately, and talks about pinning, and so this is going to dive deep into what that is. And so obviously there's a lot of things in here. So I think this is going to be the homework for myself to sort of listen to. It might be a little while before I can get to this. You just bought his book 2 weeks ago. Yeah, I've heard his book is super good. I haven't had time to read it yet. But here is the video in case you want to watch it. Let's see. I'm gonna note down that like for all of these things, it's like need to watch pinning video before working on pin stuff. And I'll just go ahead and create a bookmark to that right now. So what this means is I might be currently at this, but yeah. Currently at on hold until learning something else. So you go down into here. I guess I'll just put this at the bottom here. Well, we'll come back to it later. Which means, do I have another pin in here? I don't. Okay, so I'm just gonna go ahead and add this to my, come on. There it goes. Watch later. So I can't guarantee I'm gonna watch this before, or finish it before tomorrow. That's a lot to sort of like watch. It's over 3 hours long. So I think what we'll do is we'll just save these until later as we run into them. So that there's the other one would be the obvious like pin, right? So can I do pin? Yeah, pin. You have to wait until that. So how about unwind safe? What about you? Yeah, I do wonder if his book is going to go into more detail on pinning than his videos does. I know he said that his videos pretty much are like the notes he's taken while writing the book, which is pretty crazy awesome. And he also mentioned that there's like more stuff in the book than just his streams. So I do like that. Okay, so if we come back to here, this is unwind safe. Okay. So yeah, this is something we can do, I believe. So it's a marker trait. It's an auto trait. This trait is implemented by default for many types and behaves similarly in terms of inference of implementation to the send and sync traits. The purpose of this trait is to encode what types are safe to crotch a catch unwind boundary with no fear of unwind safety. A catch unwind boundary. The function invokes a closure capturing the cause of an unwinding panic if one occurs. This function will turn OK with the closure result if the closure does not panic, and will return error if the closure panics. The cause returned is the object with which panic was originally invoked. Wait, can I? Can I do this on any result or on any unwrap? So hold on, let's come back in here. I'm just gonna rename you to what we're actually doing, which is this catch unwind, I think is what it was called. Unwind safe. So let's say we have a function that just panics. So if I have function always panics, and we just say panic, so can I run this? So always panics dot, no, there's not like a catch that I can do on that. Oh, it's result. Oh, okay, hold on. So if you return a result, if I put in the anyhow error, I guess that could work. Yeah, that could work. So let's just say we return nothing or an anyhow error, and then we're going to return error anyhow I always pass error. Did you expect? Okay, so if we do that, this type alias takes 0 generic arguments, but 2 generic arguments were supplied. Oh, I don't want this type of result. I want an anyhow result. Okay, so now if I call always panx dot, still can't do like catch. Can I do a catch error here? No. Catch unwind. The closure provided is required to adhere to the unwind safe trait. In Rust, a function can return early if it either panics or calls a function with transitively panics. This sort of control flow is not always anticipated and has the possibility of causing subtle bugs through a combination of 2 critical components. A data structure is in a temporary invalid state when the thread panics. This broken variant is then later observed. Typically in Rust, it is difficult to perform step 2 because catching a panic involves either spawning a thread which in turn makes it difficult to later witness broken invariants, or using the catch and wind function in this module. Wait, so you can catch actual panics? Not just from results, but like full panics. Now you are auto trait. So mutable, okay, so mutable reference to types and reference to ref cells are not unwind safe. Don't do that. A reference to a mutex is unwind safe because they implement poisoning by default. Okay. It is not intended that most types or functions need to worry about this trait. It is only used as a bound on a catch unwind function. And as mentioned above, the lack of unsafe means it is mostly an advisory. The assert unwind safe wrapper struct can be used to force this trait to be implemented for any closed over variables passed to catch unwind. So can I force this? So there's this catch unwind. So I can do panic. So standard panic, catch unwind. And we have this function. Oh, it returned. Oh, okay. Got it. This is how we would use it then. So we're not doing this. You don't return anything. You just do this. Panic again. I always like what did you expect? Okay, so we panic. That's the only thing that function does. Now, if I call this, obviously, and I run this, we just get the panic and it quits the program, right? So if I try to do something like a debug hello here, we never get the hello because we panic and exit the program early. But I should be able to do standard panic catch unwind, and we're going to call always panics in here and say let our result equals Okay, so this is a result. So we get an error out of it. So let's debug result. And see what we get out of here. I don't care. We're just gonna run it anyways. And look at this, line 10, we still get our hello printed out. And we get a backtrace? Or is that the debug that happened? If I don't care about this? I still get a backtrace. So I still get the backtrace, but I also get the next lines of code. That is interesting. So what would happen if I match this result? So we get a box. Look at that, we get a box. So if I match on this, and so we're gonna have an okay, obviously, and I don't really care about you. So we just want to do a no op. But if we get an error, I want to take this error, which is this box thingy, and you're a dyn any and sent. We don't really know what you are. We can debug error. I can't debug error. Mismatch types expect. Wait, I don't want. Don't try to return. Can I just do print line? Oh, you're probably not going to implement display, so. Okay, I can do that. Is that it? Any. Well, that's interesting. But okay, so it's a box with an anything in it. What are you? I can see that you're is error, yes. I don't know how to like get the error out. Like it's an any. Oh, like maybe the string we can get out somehow, possibly, maybe, perhaps. Dot. I mean, I can downcast, but I don't know what it's cast into. I can get the type ID of it, but that doesn't really help too much because we know it's just a dyn any. So it's an anything, which could be anything. I think the interesting thing here really is though, because like this any is like not helpful. It's like, I don't know, it's something. Let's try this. If I debug error, that should be okay. Yeah, it's still this any here. All right, so what have we learned here? We can use this catch unwind to do crazy weird things like actually catch a panic in a very traditional programming try-catch style way, and then we can handle that panic as a result. So we convert a panic into a result. That's what we can do. That's so strange. So auto trait allows the, do I have like the catch unwind? I do. Catch unwind function to be run, which catches mechanics and allows the code to continue running. So don't. When should unwind safe be used? Don't. That's the answer I'm seeing here. Don't do it. It's an auto trait, which means that if you need it, it's going to be given to you automatically. So does not immediately use manually. Or maybe, you know what? It's probably best to just do, nope, don't do that. Stop. When to use it, just don't. That's it, just don't. What is this nodes and how you can use it to improve your life? Is it for writing a book? No. So this is a tool called Notion. You know, I'm curious, like, is there one of these things where I can like, no, I don't think they have like one of those like link things where I can give you credits for trying it out. That'd be cool if they did. I don't think they have it. But I think it's true. Notion.so. This is it. It is pretty cool. There is a free tier, which I am currently using, and it is pretty good. Is it similar to Obsidian? Yes and no. So the big difference between Obsidian and Notion, from what I can tell, I can do these things like this. So when I can like and then it pulls in from like other stuff, like another page or something inside of a table. So basically the big difference is I can use a database inside of Notion here. So if I it's actually, let me make sure, let's go to this one. Okay, so here I have this inbox which I put random stuff into. So let's just do like random thing, and I can add properties, and I can add like a description to this, is like a cool thing. If I add a page here and then I say something like at cool thing, can you find it? You should be able to find it. Oh, come on, don't make me a liar. Oh, I called it random thing, that's why. Random thing. And so this is now a link to this item in a full database. And then if we take a look, I have like these different projects that I'm like, oh, maybe I want to like do some cool things for like, you know, the office here. I want to buy some recycling cans. I actually have their databases and their relational databases, so I can actually link to like the project that it is. So it's a fully it's pretty cool. Obsidian is basically a very simple markdown application, so you can link to pages, but not necessarily something inside of a page. So if that's all I found when I try to use Obsidian. Maybe they've updated and it's a little bit better now. Oh, hey, I am done recording videos, so thank you, Nightbot, but I'm going to turn that off. So yeah, it's cool stuff. There's a lot of really cool things in Notion. Now the negative is all the stuff is like stored in Notion's servers. So Obsidian allows you to store it yourself on your disk drive. Notion is like not so much, which means that offline mode for Notion is not the best whatsoever. So yeah. Okay, so we just looked at Panic Unwind Safe. Oh, the any trait. The any trait is so fun. Also, ToggleBit, hello. I forgot to say hello to you. How are you doing today? All right, the any trait is really, really fun. Oh, not the right one. I want this one. Unwind safe. That unwind safe looks like really, really dangerous. Like, probably don't want to actually do it. Wait, do I just need to... Okay, fine. I'll do that. I am doing good. It is Sunday. Like tomorrow's back to work again. The weekends are always so short. Just, you know, too sad. All right, so we're gonna do any.rs. So, okay, the any trait is pretty cool. We did extensively. We used it. That unwind safe is legit. What if you're incrementing through a stream? Sometimes you just want to retry and not crash the whole app. Well, and so that's the thing is you can do that if it's something. See, I'm trying to think about like a legitimate way to do that because usually you return a result if it's something that can fail. But now that I'm thinking about it, you know what you can't get a result from that can fail and be pretty bad? Getting an index out of range. So if you try to like access something in an array or a vector and it doesn't exist in there, or like it's not that big, you just get an out of range and that's it. Like you're panicked right there. You can catch that and then try something else. That could be cool. Now, you could also do the math to like find out whether or not you should try that, and there's probably an argument that you maybe should just do an if statement right beforehand. But that is something that we could do. All right, any trait. So any trait really here is there is not something like error has error. Oh yeah. There is one of those, and I think that was on they mentioned it on results, so you can like then say like, hey, a result has an error. You can do that. You can also use the get method. Yes, you could use the get method on an the indexing type thing to like get the value or a result. I mean, yes. So like there's better ways of doing everything, but like you can technically do it. But yeah, it's like, Probably like it was the other thing is like just don't like there's other ways like Rust has provided for us. Let's not do that. Okay, so any is for used for dynamic dispatch. So specifically you do like the dyne any for the trait. It is a now I think is interesting here is it's not a auto trait. Which means it's not automatically added to everything, but it kind of is too. Which feels like strange. Most types implement any. However, any type which contains non-static reference does not. So basically, it implements on static. So use for dynamics dispatch. Any is because I think it is automatically added to anything. Any is added automatically to any type that implements that has static. Marker. Okay. Now using this is pretty cool. I don't think they really like you can get the type ID of this type of thing. Rather, any type that doesn't contain a non-static lifetime. Oh, that's a better way of wording it. Yeah. So any is automatically added to any type that has a static lifetime, really. Has a lifetime. There. Okay, perfect. Thank you. Oh, KJH. I think I forgot to say good morning or hello to you too. Technically, it's still morning for me. Okay, so to use this for dynamic dispatch, it's pretty cool. Let's say we have our location. So, which then has this X, 32, and a Y. It's an F32. And let's say we want to store this in some kind of like box that we can throw that into a struct. Yeah, then we can like then print it out. I screwed that up. Oh, I'll get that in a second. Derive debug. Let's create like a create like a debugger. It's like function like print debug print or whatever. Print debug. So I want to take in something that implements any plus the debug. So we don't really care what this type is. You're a type T. So you're going to be just like a thing, just type T. And we know we're going to have to just do debug of thing. But if we do that, we now need to register type T, and we're going to say type T is an any plus implements debug. That's it. That's all we care about. We have to pull in the any type to actually use it, and then this works. So I can then say that location is equal to x 100.0, y is 200.0. Then I can do print debug and pass it in location. And this should just work. I should just be able to debug that out, and we see that. And now anything that implements the debug trait and is also anything static, I can now print out. Yeah, debug isn't an auto trait, which is why I also have to add that in there manually. Okay, so what did I screw up here? Right. The type doesn't have to have a lifetime static lifetime. It just means the type can't have a reference that isn't static because any erases lifetimes. Okay. So let's reword this. So use for dynamic dispatch, and then basically any is added to types. So any is automatically added to types that then what was your original wording? It was any type that doesn't contain a non-static lifetime. Okay, so that don't contain a non-static lifetime. That's a double negative though. That contain a static lifetime? That's the opposite though. That's the back to the original problem. I mean, it's automatically added to types that. Let's see. Does this have any better information? Any type which contains a non-static reference does not. Oh, okay. So any is automated to most types. We'll just break this up. Types that contain a non-static reference will not get the any trait. So, what is a non-static? I don't think string doesn't implement static, right? So let's come back to here. So this works. Like I can debug location because it's these things all implement static, and therefore it's going to know what the memory size is. However, if I do, let's do another derive debug. I do another struct, like a string wrapper, like stringy. And this is going to be my string is going to be a string. I don't think this implements static. Oh, come on, Rust Analyzer. You can do it. Okay, so now if I create this, so string is hello, I am not static. That let's do toString. 2-owned and toString, like in this case, doesn't really make a difference here. And now if I try to now print debug stringy, oh, it's still gonna work, isn't it? However, stringy of A would not. Yeah, stringy doesn't have any lifetime parameters, so string static is true. Oh man, okay. What's something that's not static? It's like one of those things where I always run into something that's not static when I don't when I'm not paying attention. Now, the second I'm trying to find something not static, I'm like, what am I, like, how do I think of it? I don't know. Let's see. So same idea, like vector is probably going to be the same thing. I wish there was like a not in like the types, so I can find like not statics. Any references to local variables is not static. Okay, so I can use a reference. So what if I did a reference to a... Ooh, I wonder, can I do this? Okay. I'm gonna call this a thingy, because great variable names here. Actually, no, I'm gonna call this a location-y. Location-y. So you're like my location, but you're a reference to a location. Which, if I do that, we're gonna need a lifetime here. Now, you're staying alive long enough, although I am giving ownership of here, so that there's a problem there. Let's not worry about that right this second. We will worry about that soon. So now location A, so you are going to be our location, and you're going to hold in a reference to this location. Oh, don't help me that much. Now, cannot move out of it. Okay, don't worry about that. Location doesn't live long enough. NERS line 24. Yes, you're dropped there. Oh, is it dropping this first? I'm giving ownership of stringy. Oh, wait. Argument requires that location is borrowed for static. Yes. Okay. For line 23 is borrowed for static. So there's our error. I can't do that with the any. Thank you, Talbot. I'm so used to just only reading the first error message as the actual thing that went wrong. But that's a problem, is that it must be static for us to use it with the any for dynamic dispatch. So if I wanted to do other stuff, then like to do this, I would need to do like boxes and RC and ref cells and all that fun stuff to sort of like get the same general idea without having to just do this simple thing. But yeah, so this is an example of like how we can't use. So location, you could box leak variable to give it a static lifetime. Right, but that would be on boxes. And so this is just any. So when we get to boxes, we'll probably look into that a little bit more. So this is static, so can be sent to print debug. It's fine. But then this one, it's actually, throw you in there. Location is not static, so therefore cannot be sent to print debug. There we go. Now, can I actually still do this and send location there? I think I cannot because it consumes it, right? Oh, it does. You can do it. Yeah, that's fine. Because I just have a reference to it. This is consume. I move it to print debug. And it gets dropped here, but then everything else gets dropped, so it knows that. If I tried to debug location right here. There we go. That's causes the problem here. I was wondering about that. It must work because it knows that this is everything's gonna get dropped right afterwards. So it's like, yeah, this is fine. It's fine. Don't worry about it. Yep, NLL is nice. Except when it like confuses you because you're like, why does this work? And it's like, oh, because I'm not actually doing real stuff here. That's why. All right, so let's take this like this in here. Throw you in. Now, that's the dynamic dispatch part of it. And he has has like this type ID, which is actually surprisingly cool. So required methods. So it's this type ID. So what is type ID? So type ID lets us like creates is it like a UUID or is it, I think it's just a hash. Doesn't really say. It's basically like a unique string. I would almost call it a hash, but I don't know if it's like actually truly a hash or not. A unique identifier for a type. This is guaranteed. Oh God. Guaranteed. Spell check, help me. Okay, so this is guaranteed to be unique to the type for this specific runtime. It is not guaranteed. Okay, it's not guaranteed across different runtimes, especially when on different operating systems or just computers in general or types of hardware. When you have static as part of your trait bounds, T static, this usually means that if T has any references, they have to be static. Oh, yes. That is something I didn't really mention here. That part of this function here, I'm basically saying, okay, this T, this generic thing that could be anything and who knows, it must implement the trait any and debug together. And I'm doing that because I'm lazy, because I want to use debug. Otherwise I could just do like, something else. But I can't like reach into T, this like thing.x, because it doesn't know what that means. I'd have to create my own trait to like deal with that. But yeah, thank you for that. Oh yeah, and it does not mean that T has to live for the duration of the application. It just has to know that it means like it knows that it's static in memory. I think any is unnecessary in this example. It technically is. Yeah, well, it probably is. Let's try it. If I remove the any. It's still gonna work, isn't it? Yeah, it's still gonna work. It's unnecessary. So what I can do to make it necessary is we're gonna get the thing and then thing.typeID. That makes it necessary. I mean, it's still sort of like forcing it, but now we'll be able to see what the type ID of this is. Now, can I do print debug? Oh, I can't do the print debug of the other thing. So we're only going to see the print debug of location. And then I want to probably do a reference there. So then I can, yeah, there we go. Perfect. I can actually just do a reference here. And a reference there. It's all fine. Okay. What was I doing? I was writing all this stuff. Okay, so there you are. Now, if I want to implement the any myself, I don't have to implement the any myself. This type ID, if we get out, if I run this now, we can now see here is this like unique identifier for that type. So this is a location, and a location, and it's my own type too. It gets its own identifier as opposed to like a F32, a F64, a U32. They all get their own unique types. Nice to see some use of debug. Excited when they announced. It's like my favorite thing now. As soon as they invented it, I love it. I use it all the time. Okay, so that's like, I use this extensively inside of the ECS library that we were doing. In fact, like at the beginning of stream, we were like fix something in there, and it's actually really cool to sort of like see type ID being used. I use the type ID as the key in a hash map. So that way we can say, oh, like just store something in there. I don't care what it is. We implement any for that. Just store that inside for me. Now, can I implement this myself? So you require to be a type ID. Okay, so if I do type ID, is there like a new? I don't see like a new. Oh, do I have to just do this of the type ID of this thing? Maybe. So I could do type ID of self. Like that, and that's what I return. Conflicting implementations of any for type location, conflicting implementation and create core. Oh, so I can't do this myself. I can't do this myself because it's already been implemented for me. So I can't do it on that. Now we already know that I can't do it, that any is not implemented automatically on location. What about location E? So now here, could I do something like, you're just a wrapper around location. So what if I were to do that you are the same type? Like maybe I can do something weird. Type ID. Let's first try the of with self. No, so you don't let me do that there either. So you have an any. So I don't think I can implement any. That's good to know. So we cannot implement any manually. Now, what's interesting is that there's some auto traits in which you can implement them manually, but this not so much. And it's not even an auto trait, which is kind of weird to me. I sort of like feel that it should be an auto trait. You think RFC 1210 would allow this? Is that implement? Is there a link in here? Where do I find those? Is that just on, let's see, Rust, RFC 1210? RFC proposes a design for specialization which permits multiple input blocks to allow the same type trait so long as one of the blocks is clearly more specific than the other. The more specific input block is used in the case of overlap. The design proposed here also supports refining default trait implementations based on, okay. So I could like implement mine, but then I say, okay, I can do multiple impulse of the same thing. And he's implemented for everything there. Well, everything, yeah. Oh, but that's like impl, but T. So like, I don't know if that still does the same thing. I don't know. It's hard to tell if that would allow it. I bet it still wouldn't. Oh. Where are you? Okay. So there's that. So I can't really do anything special. I'll add in the code for the there, so we can see the type ID in there. And I think that's it for any. Any is like really cool. So the error was at impl T, any for T, and impl any for location both exist. The impl, the location has already gotten an any. So I can't do an any twice for location. Conflicting types. But specialization, the more specific version, impl any for location will be used. I guess. Maybe. Yeah, I guess we gotta have it like be added in and we can try it out. And see how much we can break our own code by implementing all these things that we shouldn't be implementing. And he's really nice using your messaging library. I know it is super nice. I like it. It is one of my new favorite ones. All right, so It is 12:19. I'm getting really hungry, and so I don't know if I want to go into borrow right now, because I don't know if I'll be able to properly do it. What is this? This is the standard borrow one, right? Yeah. Yeah, this is gonna be fairly, like, we're gonna have to go pretty deep into it. So I think we're gonna leave this for tomorrow morning. Oh, you just saw the shirt? Yeah, I wasn't sure how easy it is to see. Like, the rust outline is all in the stars, and it's not like a solid thing. But yeah, it is nice. It was not this year's, but last year's, or 2 years ago, last year's Rust conference shirt. All right, so this all thing has been good. I think we're gonna go ahead and call it for a day. So Raven Legends, sorry Zilby never came so we can pet the cat. I'm gonna refund those points to you. I am gonna go ahead and head off, go grab some lunch, relax around for the rest of my Sunday. So tomorrow I'll be back again around 8 a.m. Mountain Time, and we'll be streaming until around 9:15 or so. So about an hour, 15 minutes. So with that, have a great rest of your day, and I will see you all next time. Bye.